Let us see about projectile motion. When an object is thrown with an angle with horizontal with some initial velocity u, it takes a path of a parabola. That is called projectile. Suppose let us take it is thrown with initial velocity u at an angle theta with horizontal. Then this is u cos theta, this component is u cos theta, and this component is u sin theta. So what are the x components and y components? I have written it like x components for initial velocity is u cos theta, that is in x direction, and y components it is u sin theta, it is in the y direction. What about acceleration in x direction? In this way we don't have any acceleration, but in y direction we have acceleration, that is acceleration due to gravity. Okay, we have already seen when an object is vertically thrown upwards, at its topmost point its velocity is 0. We know it already. Similarly, here the y component of velocity will become 0 at the topmost point or horizontal or maximum height. At maximum height, the vertical velocity will be 0. So at that point, the only velocity the body has is u cos theta and not u sin theta. It will not be having the vertical component of velocity, it is only having the horizontal component. Now let us see how to calculate the time of flight. First let us find the time to reach maximum height. Here we are applying the equations of motion in y direction, that is we are going to use only y components like u sin theta, g, and we are not going to use u cos theta and these components. We are going to use only y components and we are applying the equations of motion to y components. V equals to u plus at 0. Why we are taking 0? Because we are finding the time to reach maximum height. At maximum height I told vertical component will be 0. So it is 0. U. What is the initial vertical component in y direction? That is u sin theta. This should be uy. This is also ay. Why we are taking minus g? Because u sin theta is upwards like this, g is downwards like this, g is acting vertically downwards. So it is minus g and this is t, this is time of flight. T equals to u sin theta by g. This is the time of an object to reach the maximum height. Now what will be the total time? It is 2 u sin theta by g. That is the whole to time. Again it will take a time u sin theta by g to come down. So the total time of flight is 2 u sin theta by g. Now let us see how to calculate height of projectile. So when a projectile is being thrown, it is reaching a maximum height. Let us see how to calculate that maximum height. V square minus u square is equals to minus gh. Why we are taking minus g? Again we are here also we are applying the equations of motion in y components. So I am taking only u sin theta. So u sin theta was upward like this, but g is downward like this. So I am taking minus symbol for g. Again at maximum height, vertical components is velocity of vertical component becomes 0. So it is 0 minus u sin theta whole square, because u is nothing but uy. U sin theta whole square equals to minus 2gh. So we are getting h equals to u square sin square theta by 2g. Next, how to find range of projectile? Range is nothing but the horizontal distance travelled by the projectile. So this is the range. We know in horizontal direction there was no acceleration. So it is just r is equals to ut. What is u? Here we have the distance is in this direction. So we have to take the velocity, the component of velocity in this horizontal direction only. So that is ux into time. Ux is u cos theta, time is 2 u sin theta by g. So range is u square sin 2 theta by g, because sin 2 theta equals to 2 sin theta into cos theta. Now we have to see another important thing. Range is maximum for theta equals to 45 degree. Why? Because range is maximum when sin 2 theta is maximum. Sin 2 theta for it should be maximum when sin 2 theta equals to 1. So 2 theta should be equals to 90 degree. If 2 theta equals to 90 degree, then theta will be equals to 45 degree. So this is important. Range is maximum at theta equals to 45 degree. Range is same for these angles, theta and 90 minus theta. So for theta and 90 minus theta, the range will be same. For example, 60 degree and 30 degree will have same range. Let us see the projection from a certain height. At certain height, we are standing at certain height and then we are throwing a ball or an object like this. So again, this path is also parabola. I am throwing it with an velocity, initial velocity u, with an angle theta with the horizontal. So this is u cos theta and this is u sin theta. This is the range, that is the maximum horizontal distance travelled by it, that is range. Now let us apply the equations of motion. S equals to ut plus half at square. We are applying to the y components. Displacement is h. Why? Because it has started here and finally it has reached here. See the final this displacement, you please see. So that is h. Initially starting here and finally ending here. Minus, we are taking minus u sin theta. Why? Because it is falling like this. The net displacement is in this direction. So it is starting here and it is coming here. So the net displacement is in this direction. So it is like this, downwards. H is downwards. Similarly, G is also downwards. That is also downwards. But u sin theta is not downwards. It is upwards. So u sin theta must be negative. If these two we are taking it as positive, then u sin theta should be negative. Then we are substituting h is equals to minus u sin theta t plus half gt square. From this we can obtain time. Now what about range? Range is nothing but r equals to ut. Here we are writing u cos theta because for range we have to take the horizontal distance. So this is the horizontal distance. So the component of velocity which is in this direction we should take. So that is only u cos theta. So u cos theta into time. So we are not taking any equations of motion because here there is no acceleration. So if there is acceleration, then we have to use ut plus half at square. Anyway, half at square term is 0 here. Okay. Now we are taking another case. We are projecting the object at certain height only, but we are not giving any vertical component, that is we are throwing it horizontally. Vertical velocity is 0. We are giving only horizontal velocity. So initial vertical velocity is 0 here. We are throwing it like this and it is reaching a certain range. That is a range, that is horizontal distance, and we are throwing it from certain height. Now let us apply the equations of motion to y components. So if you are applying for y components, then you have to use only the components in y direction. H is equals to ut plus half at square. Initial vertical velocity was 0. So that is 0 plus half gt square. So it is the net displacement. G is h is also like this, G is also like this. Both are in same direction, so positive. T is equals to root 2h by G. What about range? Range equals to u into t. Here u is only u, not u cos theta, because the total initial velocity is in this direction, only in horizontal direction. So we can take u. Time we know, we have calculated 2h by G, under root 2h by G. This is to be remembered and this is also to be remembered. Now let us see the equation of a parabola. Y equals to ax minus bx square. Y equals to, here for projectile this is the equation, x tan theta minus g by 2u square cos square theta x square. So we can compare a to tan theta. Here a is nothing but tan theta. Compare b and this one. B equals to g by 2u square cos square theta. This is a simplified form. Range we can calculate from this by using a by b, and h max is a square by 4b. This is for easily calculating. Range is a by b and h max is a square by 4b. Thank you.